we are going to perform the experiment that is going to find the moment of inertia by flying. We have already know what is an inertia. Inertia in mathematical form, I is equal to mr square. It means mass is the product of mass and the distance, perpendicular distance, square perpendicular distance is known as inertia. Okay. So what we are going to perform over here, loss of potential energy is equal to gain in kinetic energy plus rotational kinetic energy and plus energy used to overcome friction. We will take, these are the apparatus we are going to perform this experiment. You can see this is meter rod, this is stopwatch, the slotted weight with thread, the vernier caliper, or you can use the calculator for the calculations. Students, what we have to do first of all, we will see the first, this is a flywheel. What is a flywheel? Flywheel is a heavy mass and the axle is passing through the center of mass point. Right? So, the first thing what we are going to do, we are going to take the vernier caliper and find the diameter of this axle. This is axle, and we are going to see what would be in the main scale, and you can see in the main scale there is 2.1. and then division which is coinciding with the vernier caliper, the 4 division. So it means we are going to take the radial diameter. What is diameter? It would be 2.2 centimeter. This would be your diameter. When we are going to find the R is d by 2, it means 2.2 divided by 2, it becomes 1.1. So what is the value of R recorded? This is 1 centimeter. So after finding the diameter of an axle, we are going to take the slotted weights with the thread. First, each weight is heavy. Each weight is 50 grams. I'll show you. This is mass with hanger. This is also 50 grams. So what I'll do, I'll move towards the flywheel and make a loop around this knob. I have made the loop. Now, the students, what we are going to do, we are going to turn around to find the number of turns on the axis. See over here, you can see, just pick up two. These are the number of turns. 1, 2, 3, 4, and this is 5. So how many turns I have on this axle? This would be represented in the observation would be small. How many number of turns? This is 1, 2, 3, 4, and 5. And then I'll take the scale, the meter rod. With the help of the meter rod, I will notice down what is the height of that mass. It should be done like this. This would be your height. And you can notice the height with this. This is 58.5. You can see 58.5. What is the height of that mass? 58.5. So after that, we are going to note down how many turns on this axle, the small axle. 1, 2, 3, 4 and 5. And what is the height? 58.5. And slowly I am going to leave this. Before that, I am going to use 100 grams. This would be my mass. This is mass with hanger, it would be the 100 grams. Slightly I am going to, it will follow down, and when it strikes on the ground, on the floor, I will start the counting for it. I started it and I am counting this 1, this would be 2, this would be 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. When the mark passes through it, you are able to 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, and this is 35, 36, 37. I will wait when it would be stopped. Now I have stopped the stopwatch. You can see what is the time on this stopwatch. This is 1.43. It means we already knows 1 minute is equal to 60 seconds, and when I am going to add some more, it would be 103 seconds. So we have done we have taken the first observation. So you can see over here how much mass we are hanging on that. I will show you that. The mass which is hanging around the axle, that was 100 grams. So I am going to write it over here, 100 grams. What is the height of the masses? That was 58.5 centimeters. How many turns of the thread turns I am talking about? That was 5. And it is represented by small n. How many rotations we have counted? That was 37. Again you can write that 37. The mean would be the same, 37. How much time we call it during these rotations? That was 103 seconds. So I am going to write over here 103 seconds. Again 103 seconds. And then again 103 seconds. So I have completed this. For this, you are going to take this with the help of the formula 4πn. What is capital N? That is 37. So 4 multiplied by 3.142 multiplied by 37 and divided by time. How much time we have? 103 seconds. So I've got it 4.51. This is the value I have got it. So I'm going to write it over here. 4.5. You have seen this. Now, how are we going to find the inertia for this? That is n into n. I'll show you the rough work of it. That is, what is n? How much is n? That is 37. How much we are in the mass? That was 100. How many? Capital N plus small n. How many when we have like this? 2gh. This is 2. 9.8. Height 58.5. From the observation we are going to take the h. This is h. This is g. This is n and this is small n. This is capital N and this is small n. You can see. Over omega square. What is the value of omega? 4.51 the whole square minus r. What would be 1.1? By this we are going to find. First we are going to multiply by this. It would become 3700 divided by 42. Then 2 multiplied by 9.8 multiplied by 58.5. 46.6 divided by with the 4.1 square, that is 20.34 minus with the square of that one, it would become 1.21. First of all, we are going to divide this one. The 3700 divided by 42, we got 88. 88.09. And in the bracket 1146.6 divided by 20.34, we got the value 56.37 minus 56.37 minus 1.21. That would become 55.16. It would become 88.09 divided by this. We got 55.16. When we are going to multiply by this, we got the revolutions 5, the spinning period 585.9.0. So this is the inertia we have found it. This is the amount. I have shown you the calculation how we are going to calculate these values. So I am going to write it in the last column. It would be 4859.04. This would be your inertia. For the second value, how we are going to take the second value of this moment of inertia? We are going to change the height as well as we are going to change the mass. Now here is 100. I will take another 50 grams and place this in angle it would become now it would become 150 now. Again I'll go over here, I'll move towards over here on the flat wheel and on along with the axle of this flywheel. Again I'm going to place the number of turns. This would be a way going to take the number of turns. Now this time you can see this will be your first, second turn, third turn, 4, 5 and 6. Now how much I have taken the turns on the axle, that is 6. Before that I have taken the 5 turns. Again I am going to note down with the help of this meter rod. I am going to see the height of that one and note it down with the help of this floor. You can see now it's 61.5. 61.5. This is the height. You have to see how much number of turns you are going to give it over here and how much, what would be the height from this floor. It is 61.5. Remember these things. And when you slightly drop this, take a stopwatch. And when it falls off right on the floor, you are going to start the stopwatch. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50. The mark you are saying 51. When it passes through it, you are going to mark 52, 53. You can see this, the mark on it. 57, 58, 59, 60, 61, 62. So we got the time over here 2.9 second over here. You can see. So how many masses I have suspended on that angle? That was 150. What is the height when I take the hangers on the height? That was 61.5. How many turns I have shown you on that axle? that was 6. How many rotations we are having? This was 61. This is also 61. The mean should be 61. What is the time on that? 2.09. It means 2 minutes would be your 120 seconds, and then plus 9 it would become 129 seconds. So I'm going to write over here 129, 129, 129, and then I'm going to find it by the help of this, with the help of the calculator. 4 pi n divided by t. 4 n, what is the how much? 61. What is the time? 129. He has given you 5.94. You have to write it 5.9. 9. This is the value here. I have shown you here. The same procedure we will do this with the help of the. Again, I am going to write the values. How many n? This is capital N. The formula is written over here, the n. How much n now? 61. How much m? This is n. This is 150 multiplied by 150 divided by n plus n. How much n? Capital M was 61 and small m was 6. 2gh, 2 multiplied by 9.8. What is the height? That was 6. Height is over here, h is over here. See, this is height, and now we need to write it over here. 61.5 divided by 61.5 divided by the help of this square, 5.94 square. What is the value of R? 1.1 the square. With the help of the calculator, 61 will multiply with the mass. That would 9150 divided by 67. One two zero five, and I'm going to take the product of this. $35.28 minus with the square of 1.1 square, it becomes 1.21. Then 9150 divided by 67, we got the value 136.5. One two zero five divided by 35.28, it would become 34.15 minus 1.21. First we are going to solve this bracket. 136. We will get the 32.9, and this would be multiplied with this 136.5 So we got the revolution, that revolution is 4497.03. So whatever you are going to calculate these values and you are going to write it in this observation column over here. And the same procedure you are going to do how you are going to add the masses. Now it would be the 200. See the number, now you are going to change the turns and also change the height. By this you are going to perform the experiment. This is all what I have to say.